So that was good. I thought the screen wasn't going to work and that we were going to start late, but we've got 1 second to go and it's 9:30. Hi everyone, my name's Phil. And I'm with a company called Respondly. And today I'm going to talk about the harnessing the power of UI components, which I believe we're on the cusp of a really exciting time in UI development for the web. And if we look at this transition that we're going through, we start with pages and we're transitioning into apps. And what that means is very loose because these terms are very loose, but we might look at the difference between stateless clients and stateful clients. And I'll drill into that more as we progress. But really, this is UI on the web, which is the new way of doing UI. But really, it's not. It's the new old way of doing UI. So what do I mean by that? Well, to unpack that a bit, let's look at a brief and completely highly partial history of user interface. So we roll the clock back all the way to the 50s and the 60s. We start with the mainframe architecture, where we see smarts are entirely on the server. And I love this ad. On the terminal, these guys were actually crowing about how dumb the client was. Like, that was the feature. Dumb as. And kind of that rolls forward, and then this renaissance happens in the early 70s. The Xerox Park, Palo Alto Research Center kicks off. It's a picture of Alan Kay there, and we see this enormous flowering of modern concepts, including the graphical user interface comes out. But we also get Smalltalk, the first instance of an object-oriented programming. The concept of objects come out of that. GUIs, overlapping windows, the discovery that if we had these very limited screens, that the concept of overlapping stuff was critical to get anything done. I love the fun fact, Alan Kay was famous for wanting to design computers for children. And the GUI, which he came up with, the graphical user interface, was never intended for anyone other than children. This was a 6-month on-ramp, and then they'd be off to using something else. But it was such a powerful concept, we never really got past that. So when we look at the 70s, by the end of the 70s, we've seen the model view controller pattern has emerged as this novel way of organizing UI. And what does that mean? Well, by 1984, we see the first commercial implementation of the ideas that came out of Park with the Mac. And this sort of rolls forward, right? We got the Mac, then Windows comes on, emulating these same ideas. Java emerges, and we got Swing, and just sort of like trying to normalize UI across these different platforms. But the fundamental thing is these aren't connected devices, they're not on the internet, and all the work is happening on the client in some form of model view controller pattern. And then 1993, this happens, the web browser, and boom, this page paradigm emerges. And we have smart servers and dumb terminals, and we've got something that looks really similar to where we started in the 50s with the mainframe. So that's 1993. By 2000-ish, we're moving from actually just consuming content to doing real work, like some kind of productive, stateful work operations happening in these page-based browsery things. So we start calling them web apps. So circa 2000, Basecamp turns up 2004. And what we start to see here is that we've got dumb client MVC, right? And then Rails emerges and it like really wraps this beautiful encapsulation of MVC, but it's still all the smarts are on the server. Page redraws. A year later, Ajax emerges as a concept, even though it was there way earlier with IE. The term gets coined, and we start to see another endpoint emerge from the API, and we start seeing things going across the XML HTTP request object. So some of the smarts are now moving to the client. We get a bit of JS, JavaScript going. And then boom, 2007, this happens, kind of like as a side, but huge, right? Because the phone happens, there's this huge growth curve on this, and what it is a stateful client, and it's really resetting expectations in the user's minds around stateful clients. So getting back to the browser, by 2012, we've got HTML5 emerging, and we see, you know, the JavaScript wars, the engines there are in full swing. We've got really fast JavaScript. So now we have full model view controller back on the client, thin servers, and then we roll it forward to today, which is like, where's the cusp? Where are we at now? Which is that only real-time kicks in. It's real-time, lots of little changes happening all the time, lots of connected clients all updating, everything's happening everywhere, servers are updating, servers are listening to each other. In this case, I'm emphasizing a relatively new framework called Meteor, which we'll drill into a little bit. So the smarts are everywhere, and just to recap, this is the new old way, right? Smarts on the server, then we move to smarts on the client, then we move back to smarts on the server, and now we're here today, which is smarts on the client, or arguably smarts everywhere. So what does this mean for us, web developers? And I'd say what we do now is looking a hell of a lot like native app development. More than at any other time in the history of web development, we're really thinking about this, and we have a tool chain and a framework that means we have to start thinking about apps in a native form and start looking back historically at what were the patterns that helped us organize this, helped us keep this under control. So, from a complexity standpoint, if we've got like no JavaScript down the bottom and then a ton of JavaScript up the top, and we're moving through this and getting more and more JavaScript, we go from easy to hard, and this is like Ajax kicks in, and this is like getting hard. There's lots of moving pieces all over the place. And you might expect that as we continue this progression, we're going to keep ratcheting that up in terms of difficulty level. But I propose that that's not going to be what's going to happen if through clever architecture we can get smart, we can make this easier. So how? Well, by way of analogy, this is what I'd like UI to be like, this beautifully pristine, gorgeous Zen garden. Everything's in its place, everything's nicely curated, there's edges on stuff, stuff isn't bleeding into anything else, it's clean. And of course, we all know with UI development, we turn around for what? A lunch hour, and boom. Right, everything, there's tendrils going out, we've got cross calls across everything, it's horrible. So if we want to get back to our Zen garden, what are our main patterns? And we've got isolation and we've got encapsulation, kind of our two main moves. Now, isolation and encapsulation is very hard when the UI is constantly rebuilding itself on every page redraw, and then we have this split between geographic locations of where that actual component is operating. However, once we get into a stateful client where we load this app once, it's up there, and it's not going away, we get this incredible opportunity. It becomes much easier to encapsulate things. And we can now look at this as somewhat like a biological cell, which incidentally is where the original idea of object-oriented programming came from. They were looking at modeling real-life systems, wondering why is it that these incredibly complex living systems could actually scale up with complexity, and it was because they wrapped everything, put an encapsulation around it, and then made this very conceptually simple interface point through, in this case, the cell boundary. So with us, by way of analogy, that cell boundary is the API. And we've wrapped whatever internal complexity is going on there, whether it's ugly or whether it's clean, doesn't matter, no one can see it. So, here's another analogy. If we're looking at an application, and this is a fractal, that we have this tree, we have these scales of complexity. If we look at a real-world example, this is Respondly. So there's a bunch of stuff going on here. There's real-time streams and feeds and bits and pieces. And if I go up the top right, I can click on a follow-up button. Follow-up brings up a drop-down, and then the drop-down, you can drill into the drop-down. And boom. Really, this is a complete little mini application. It's a universe unto itself. It doesn't know about anything other than itself. It has its internal complexity going on. But we can narrow in on that. And in fact, even that which looks relatively simple, is about 8 little mini applications running on their own, not knowing about anything else, but working in concert. Drill in further, right? There's about 3 things going on there. There's a list, and there's people, and there's the ability to do quick keys, and there's a search term text box. When you drill into that, there's a search, and then that unloads to have a relatively sophisticated API on it. So why is this good? Well, it's good because when we isolate our UI modules, we isolate our problems, right? We take a big, gnarly, dirty problem and we break it into lots of little, hopefully not so dirty problems. And when something goes wrong, we can drill into any level and fix that without the complication of the rest of the application getting involved and side effects. And we can scale in and out. At any point, we can go, hang on, this isn't working. Well, I know it's not all of these smaller pieces, but it's not like the whole app. There's some level in the middle of that fractal that I can go in, if I can isolate that as a unit and fix it, I'm in a better place. Which leads us to HTML5 and HTML5 components. Now, we're kind of on the cusp of this, right? We've got really cool things like Polymer, Shadow DOM, Xtag, like these advanced things that are almost here. We saw Chris talking in the last talks, like kind of here. It's going to be here. The polyfills work, kind of. But then leading up to it, we've got all these other, component technologies that use what we have today. And in essence, it's just bringing these 3 things together. JavaScript, some kind of templating language, and CSS into a component with some sort of formal API. Some way of saying, I don't talk to any of that junk that's inside it. I talk to a logical abstraction around it. And the examples I'm going to show you, I'm using Meteor, which is one of those component systems, one that I think is particularly good with isomorphic JavaScript everywhere, and an extraordinary build system for packaging all of that together. So this leads us to the question, how do we build these things, right? And more importantly, how do we test them? Now typically, I don't know if you've ever done this, I've done it most of my career, we throw a web page together, right? And we put the control in it, and then we put a bunch of links and buttons, and we click them, and we manipulate this thing. For example, right, here's our little search box. I can do a little dance with my mirroring, so hopefully this works. Boom. Boom. And here's an example, right? Simple web page. This is the actual control, and I can test it, and I can manipulate it. And then I have a bunch of buttons, which are just buttons and event handlers hooked up, and I can like click things, and I can, okay, toggle enabled, do that. I've got it into a state where it's not a text box anymore, put some long text in, But basically what I'm doing here is I'm manually exercising both the control and the API in a way that's essentially ad hoc. That's a really natural way of developing. Let me jump back to the Prezzo. Now, if there's a show of hands, has anyone done something like that? Right. And it's really cool, right? There's some really nice aspects to it. It's highly flexible. You can do anything you want. You have manual manipulation of the UI, which is critical for when you're building it, right? Like it's not there yet. It's not a final thing. You've got to like change it, test it, see how it goes. And then you've got programmatic manipulation. But what I'd say is there's a bunch of stuff that's lacking there. Firstly, it's ad hoc. There's a whole bunch of work that you have around the edges of creating those event handlers. And it gets rusty, right? Like you move forward, the control moves forward, the test page gets rusty, you come back to it, none of your tests work, you may as well throw it away. And so we have this other thing in our tool belt called unit testing, which is a different world entirely, but it has some really nice aspects, right? You can describe behavior through a formal specification. You have assertions, so you can assert correctness. Is this thing what I expected it to be? And of course, we all know unit testing or testing UI is notoriously weird and difficult. And then once you can do both of those things, you can run test and you can assert correctness, then you can plug it into an automation chain, right? Continuous integration. And so what I posit here is that there's this pattern, and I'm calling it the UI harness, And I encourage you all to look at this and build a version of what I'm about to show you for your favorite framework. But it fuses both of these things, the beautiful flexibility of ad hoc scaffolding with the formal automatable notion of unit testing. So there's a website there, uiharness.com. This is a thing that I'm building for Meteor. But as I say, go and build this for everything. Let's have a look at it. So I'll do my little screen dance again. See if the screen gods are with me. Yes. So here's what this looks like. I'm going to open up our private controls, and we have a list over on the side here, and say let's drill into this. And let's have a look at, say, user selection list. And that's this thing that we're talking about, right? So from that whole application, now I have this thing. And I've drilled in on it, and I can go, oh, what if I do this? What if I'm not on that list. Who is on that list? Helen. So I'm doing manual manipulation here. But then over on the right, I can do things like show or hide the hint keys. Is it a pop-up, or is it an embedded thing? Set a maximum height. I won't do that. I can change the placeholder on the text box. That's my placeholder now. Multi-select, just select one item, select all items. But we see we've got both of these things. I'm manipulating the API manually, and I'm also manipulating the API programmatically. So why is that any better than this? Right? We've got a bit of a structure and a bit of a visual formatting change. But how is that better? Let me jump back and introduce one concept that I think is pretty cool. So there's this semantic structure around unit testing that grew out of the Ruby community in RSpec called behavior-driven development. We get this semantics given when then, in this case, describes something, it does something, and then we can assert, we can run some code inside there and assert it. So that's in JavaScript. I prefer the CoffeeScript version of this. Describe my thing, it does something, and then I expect something will happen. Now that's a formal unit testing domain-specific language, but it works perfectly well for building an object graph and then getting that up in UI. And in fact, that's how the UI harness works. You just write these styles of tests and you get UI automatically generated. And so what we're doing is collapsing the amount of work you need to do to get your component up and testable in a repeatable way. Because now it's a unit testing framework, we can rerun it, we can see when stuff breaks, we can fix it as it breaks, and we keep all of our tests up to date. So let me show you. Again, mirror display. And we're back. So where were we? We were looking at a set of controls, but let's build one. Let's see what it would take to get that text box under test. So I'll bring up some code, and if we're looking at, say, the root of the test harness here, I'll write a describe statement. We're in a conference. So I'm going to describe the conference. And then within that, let's nest a describe statement where we're going to look at a text box. If I can type. And so what we see here, and what's happening here under the hood is that Meteor's build system has recognized the change and it's doing its isomorphic build magic, and it's pushed a new version of this to the client. And I drill in, and I can see that we're inside the conference suite, and then we have a look at the text box, and we're inside a view of the text box. It's not doing anything yet, but we've now organized a way of doing that with 2 lines of code. So before anything happens, let's load a text input. And I'll set the size to be, say, 400 and of auto hide. So now that's reloading, and we've got a text box. There's not a lot going on. In fact, what I'll do is I'll put a title in and subtitle so we can begin to tell a story about it. and the thing becomes self-documenting. We can start to say, this is what this thing is, this is how we use it, this is what it's for. Now, some things. Let's say, let's put a label on it. I'll grab a reference to the control, my label. Let's set some text programmatically, say. What if we put a message? So we can start to exercise the API of this control. Not that. Dot message. I'll put some lorem. Let's say put 30 words of lorem in it, and boom. What do we got? So now we've got our ability to express a story around this, and this will grow. Being able to put markup, being able to put documentation right next to the control. Let's set the label. So we can set a label, put some text, dunk a message on it. These are just things that control does, but the ability to do that took 3 lines of code. Now what if we wanted to do that required thing? Right, so there's this notion of a text box, a value being required. And in this case, that's a Boolean value. So what we could do is go, it is required, and then it is not required, right? And this is something that we do all the time when we're doing this sort of testing, right? As we go, oh yeah, put it into that state, and then put it into the other state. So we have to write 2 lines of code to do that. So it is required, it's not required. If we put a label on there, we can see the behavior. But that's 2 lines of code, which is nuts. Why would we want to write 2 lines of code when we know that it's a Boolean? So in this case, we say, we know our control has a method, it's called required, set up a test where we can toggle that. And now we've got that. Another example, say we want to put a selection list, and it'll be text. Foo, ba, baz. And now we've got the ability to test all of that. And because it's so concise and so formally structured, we can begin to put assertions into this, we can begin to automatically run it, and we can get it involved in our CI server. So let me quickly jump back to the slides. And see where this leaves us. So just in final wrap-up mode, to recap, when we isolate our UI modules, we have this tree of complexity. We isolate our problems, and we can drill in and out of the complexity at any level if we start to write tests in this way, if we start to break the UI up into modules and then get those modules out in a way that we can prod and manipulate them. And through clever architecture, using the technologies that we have today, things can become more complex but be considerably less difficult to build. So this is a design pattern to build and test, isolate UI, document UI. We've got one implementation that we're building at Respondly. This is how we build the Respondly app out, is using this. We built Respondly on the Meteor framework, so this is a package that will be released. Meteor's marching towards 1.0 release, and when that gets released, we will publish this into the public. But as I said before, this is a pattern that is universally applicable. So whatever framework you're using, I encourage you to build something that has these qualities, that lets you rapidly build and get and host your UI component tree and then manipulate it in a reusable, ongoing fashion. Thank you. Shall we